Hello everyone, I'm Hyung-nok Kwon from Capco KDN. I'm in charge of AMI server system development. Let's start the presentation now. My presentation title is Method of Estimation of Missing Data in AMI System. Let me tell you about the background of the study. This image is AMI infrastructure. The AMI infrastructure is about 50% complete in Korea, about 10 million meters. When AMI installation is completed at 100%, a number of new services will be created to help real life and make many changes. The communication equipment that constitute AMI, especially in Korea, use more than 90% of the power line communication network. Due to the environmental impact of signal attenuation, which is characteristic of PLC communication errors in the communication process, such as poor communication or malfunction, can result in missing value of data, resulting in a problem of poor quality of data. Let me tell you the objective of the study. In this paper, we analyze the time series data measured from smart meters in this technical background to determine the missing of smart meter data and discuss the data processing method that replaces the missing value with a specific value. This picture shows the data collected from meter. As you can see, power usage is cumulative usage that continues to increase. Some sections of the collected data were missing. In this paper, we would like to study how to estimate missing data. It is assumed that data exists only before and after the missing section. In other words, only cases where data is missing in the middle were studied. This page is related work. First, linear interpolation method. Linear interpolation is a method of linear calculation according to straight distance to estimate the values located between 2 points given. From M1 to Mn is missing data. P1 and Pn are existing data. N is count of missing data. Missing average value is Pn minus P1 divided by N, and M1 value is P1 plus missing average value. M2 value is M1 plus missing average value, and Mn value is Mn minus 1 plus missing average value. Second, replacement of similar faster situation, a method of estimation missing data using similar historical power usage patterns. First, using Euclidean distance to find a date with similar electricity usage. Find from Q1 to Qn similar to the pattern from P1 to Pn. The subsequent value of a similar pattern is a reference value. And then M1 value is Pn plus R1. M2 value is M1 plus R2. Mn value is Mn minus 1 plus Rn. Third, ARIMA predictive estimation method. The automatic integrated moving average model is a generalization of the automatic moving average model, which uses the previous observed value and error to describe the current time series values. Fourth, LSTM predictive estimation method. Use LSTM to predict the amount of section usage for missing section. Estimated the first missing data by adding the predicted section usage to the cumulative usage just before missing and the predictive section usage. Next, the second missing data is estimated by adding the second predictive data to the first missing collaboration data. This page is result and discussion. For the experiment, 1,000 customers from general household were randomly selected. The 2 months power usage data were selected for the period. For the missing experiment, the data was removed from the original data without the missing data and experimented. The experiment was conducted assuming that 10 hours of data at a specific date were missing. First experiment, linear interpolation method. This table is the sample data. Step 1. Subtract missing data from the first data after missing. This will result in the total electricity used of the missing section. Step 2. Divide this value by the number of missing sections to make the average use of the section. Step 3. The first missing value is the addition of the interval average usage to the missing data. The linear interpolation method estimation the missing section by dividing them into a constant so the graph estimation them in a straight line. However, the actual data subject to the same error because of change in usage over time. This linear interpolation method would be a good fit if the amount of change in usage was a fixed time zone. Linear interpolation can be calculated quickly and simply, while saving resources such as CPU and memory. This page is a replacement of similar past situation. A replacement of similar past situation is a method of finding situation. In the phase in which power usage patterns are similar and estimation missing data by referring to the usage at that time. In order to apply this method, it is first necessary to find fast similar situation for individual customer. Power usage data features working day and holiday with similar patterns on a weekly basis. Therefore, it was limited to 7 days before the late date of the missing to find a similar situation in the fast. The similarity used the simplest Euclidean similarity, choosing the date with the smallest error. The amount of section usage in the same time zone in the fast similar situation is added to the cumulative usage before the start of the missing section and the segment usage in the reference data in the same time zone. The data from the missing start point are estimated by adding up the amount of section usage at the time of the fast similar situation, indicating that the first error is accumulated as the estimation is carried out by time zone. The limitation of this method, the last data of missing estimation is greater than the first data presented after the missing estimation, resulting in a fatal error of negative value when used for power usage estimation. This page is ARIMA predictive estimation method. The method of prediction using ARIMA algorithm, a traditional method of time series prediction, show very good performance in time series field. To predict the ARIMA time series, the method of running by entering data for 7 days before the time of the missing and predicting data for the missing section was used. ACF and PACF were used to determine the PDQ values of ARIMA. To apply the ARIMA model, input the actual data without using the segment usage, and if differentiating the ARIMA model D by 1, then to certify the stationarity of the data. The limitation of this method, the last data of the missing estimation is greater than the first data presented after the missing estimation, resulting in a fatal error of negative value when used for power usage estimation. This page is LSTM predictive estimation method. The LSTM model's input data used the cumulative data as well as differentiating segment usage data. Using LSTM model was used to predict missing data after running. The predicted data then predicted 24 hours segment usage data. The first cumulative usage, LSTM estimated, was estimated by adding the estimated power usage of the first hour to the cumulative power usage of the time zone before the start of the mission. Next, the second data was estimated by adding the second forecast to the first estimated data. Left image is the model summary of the sample data. Right image is result graph. Blue line is real data. Orange line is estimated data. LSTM predictive estimation method showed very good performance. But the limitation of this method, the last data of the missing estimation is greater than the first data present after the missing estimation, resulting in a fatal error of negative value when used for power usage estimation. Next, discussion. Except for the linear interpolation method, the other methods have increased the value of the mean absolute error over time. The reason is that the error continues to increase because the predicted estimated value are calculated by accumulating in the previous time zone. The best result of the 4 experiments were obtained by linear interpolation. Except for the linear interpolation method, the other method fatal error occur in which the power usage is negative. In fact, 303, a customer have experienced negative power usage. The LSTM predictive estimation method may perform well on some targets, but it can be used if such cumulative usage is negative. A fatal error occurs in which the power usage is negative. Final page is conclusion. In this paper, 4 methods were experimented and the performance comparison. Since the power usage data continue to increase in cumulative value, the error value becomes more and more aggressive as the cumulative usage value is estimated by the prediction of the segment usage and the missing segment usage is added to the time zone usage. Since power usage is not a typical time series prediction data, but rather estimation of data that result in an intermediate missing, a simple prediction can cause error that reverse the data that appear after the missing. In this paper, for this reason, the linear interpolation method is more stable and has better performance than the general time series field prediction estimation method. In the future, to estimate missing data in the AMI system, we would like to conduct a study of hybrid method combining the advantage of linear interpolation with the advantage of time series prediction estimation. Thank you for listening.